Well, while we wait for everyone to arrive, my name is Pascal. I am the channel and marketing content manager for Fresh Air Systems here at Broan. I'd like to thank all of you for joining, including our presenters. Anytime we have the chance to support and educate the industry, it is a huge step in the right direction to fulfill our mission. In the past few months, Broan has received questions from multiple customers and partners, including builders, energy raters, contractors, about the upcoming changes regarding the 45L tax credit and Energy Star version 3.2. The goal of today's meeting is to provide a better understanding of those changes as to why they are happening and to offer solutions and guidelines to achieve certification and for you to maximize your investment. As you can see, your mics are disabled, so please use the Q&A. The chat is also disabled, and ask your question during the webinar. We'll have some time at the end to answer them. You will hear from our product experts at Broan. Patrick, Technical Product Manager, is here with us, as well as Heidi, Senior Product Manager from our exhaust ventilation category, and Travis, Group Product Manager for Fresh Air Systems. You will also hear from our special guest, Gord Cook, who has been a partner with us for many years. So welcome, Gord. Thank you so much for being here. I think it's time to jump right in, and maybe before we do, you can tell us a little bit more about yourself.
Thank you, Pascal. Maybe we'll go back to the agenda slide just quick, just so we can outline that for folks who may have just joined. You've asked me to do a little bit of a task of kind of just reminding people of the opportunities associated with Energy Star generally, and then Energy Star version 3.2 specifically. I guess this is well suited to my background, as we help builders in construction instruction. We help builders across North America, quite frankly, meet requirements, A, just for minimum building code, or B, for upgraded programs like Energy Star or DOE's Zero Energy Ready program, or LEED programs and passive house. We're a building science firm. We have an education center in Denver, of which we're very pleased that Broan is a partner in that building. If you want to learn more about construction instruction and learning opportunities, by all means, look up constructioninstruction.com. We'd love to see you down at the building, where we have an interactive learning center, about 12,000 square feet. We have a little house built in it with 3 different mechanical systems installed, plus many different ventilation systems, plus we have wall sections, water testing, building science lab, and so on. So I just encourage you, if you want to know more about these topics, we'd be happy to help with that. And then as part of this agenda, you can see I'll pass it off to Patrick and Heidi and Travis and team to talk about specifics of how ventilation systems can help you meet those requirements of Energy Star 3.2. But perhaps I will get started if we could click to the next 2 slides, I guess. Thank you. Did we want to be on full screen, or are we going to leave it as, I guess that's fine the way it's listed. Yes, thank you. So I always like to start with that history. I think it is interesting to note that the Energy Star label is an EPA-owned label, Environmental Protection Agency, initiated in 1992, really to promote energy-efficient appliances at that time: computer screens, CRTs, televisions, dishwashers, washing machines, and so on. And I think everybody would understand what that's about, and have seen a label before. But important to note that in each case, the label was to denote a product that was somewhere between 10 and 30% better than the average fridge, the average dishwasher. And in that same vein, there was a label designed for new houses in 2001. And the premise was that an Energy Star qualified home, when it was stickered as Energy Star, would be at least 10% better than the prevailing code of the day. Now, that's kind of interesting in itself, because most of you on this call may know that the code is not evenly distributed across North America, and certainly not even across the United States. So different states have different versions of code. But the promise of Energy Star was that we would always be at least, or they would always be at least 10% better, and as much as 20% better than an average house. And it indeed has been a very significant program, the most popular energy efficiency program ever. Over 2.5 million houses and counting labeled to date since 2001. It is adapted for each state or region, as I just mentioned, but it is getting, because of the, I would say, the squishing of codes getting down to the end, the new versions, version 3.1 and 3.2, are indeed a little more consistent now across the country. But it is important to note that as codes have improved, new versions of Energy Star are introduced. Somebody asked me just the other day, will Energy Star ever become code? Well, it has. Energy Star, whatever is Energy Star today, will indeed become code at some point, and then at which point Energy Star has to go up again because its promise is always 10% better than prevailing code. And one of the most important aspects from a consumer's perspective is that it always includes third-party verification. That is, it's not just the builder saying this is an Energy Star home, or the products in the home that are indicated as Energy Star, but in fact there's a third-party oversight that tests and specs and makes sure that all the requirements have been met. So that's pretty powerful, at least in my mind. Go to the next slide if you wouldn't mind. And there are these really compelling trends, as I mentioned, that every 3 to 5 years, the code changes, the ICC code changes from 2006, 2009, 2012. All of that, to a large extent, at the top left, they're predicated on HERS index or energy rating indexes to kind of give us a sense for how they're at. But inevitably, every 3 to 5 years, this 15 to 20% improvement in performance, which kind of matches the Energy Star promise, right? 10 to 20% better. And as we follow along the path, the next version would be, say, DOE's Zero Energy Ready program. What happens to include also WaterSense and EPA's Indoor Air Plus program. EPA's announced a new program called Next Gen, which is effectively an electrification of houses. But most important for today's conversation is there's been some nice tax incentives associated with this for builders, that the 45L tax credit, which will be in vogue, and Pat will give you more on this in a bit, up to $2,500 for houses version 3.1 permitted after January of 2023. That is houses of now. As of January 1, 2025, houses acquired after that point would be have to be 3.2, version 3.2, in order to get that $2,500 tax credit. And indeed, a $5,000 tax credit for Zero Energy Ready houses version 2 for any houses enrolled after last January 24th. So not only is this a compelling program, advantageous for homeowners and builders, but now there's an actual tax incentive that is available to builders for that. And if we went to the next slide, thank you. And just so we're all clear, there are, it's a pretty straightforward program. The essential parts of Energy Star is that you have this complete thermal enclosure system with properly installed insulation that's third-party verified, comprehensive air sealing, which is third-party verified, high-performance windows, which is third-party verified, and then higher efficiency HVAC, domestic hot water. And in today's context, an emphasis on indoor air quality features and specifically proper ventilation, understanding that EPA recognizes that when they put the sticker on the Energy Star sticker that would be indicative of higher energy performance, they also know there's a burden or at least an expectation that houses are going to be of better quality. And one of the most compelling features of Energy Star is that it's also encouraging proper indoor air quality control, which starts with proper ventilation. And then things like water managed construction details, qualified Energy Star lights and appliances. And then, as I mentioned one last time, those independent inspections and tests. So pretty powerful essential elements. If we could go to the next slide. And from a consumer perspective, if this is just a screen grab from the Energy Star website, but this understanding that what consumers are going to get out of this, homebuyers are going to get, is the peace of mind, the result of better design and construction, the enduring quality, better systems make all the difference with respect to the investment that people are making, that they can be assured of the quality. And it is important to understand when surveyed, and they are surveyed, people who buy Energy Star have at least two expectations. One, that of course the house will be more energy efficient, and two, that the house will be of higher quality. They don't necessarily recognize what quality means to them, but in terms of the bottom left there, the wall-to-wall comfort, this better way to live, from the moment you walk in the door, you'll feel and see and hear the difference between the way these houses are built, which gives you on the bottom right the understanding of better value for that house, both now and in the future. And part of that quality is indeed the aspect of good indoor air quality control. You can imagine homeowners aren't too excited if they get an energy efficient house, but don't feel healthy inside that house. So it's always been EPA's task is to make sure that it's not just an energy focused program, that it's an energy and quality focused program. Next slide, if you wouldn't mind. And just so we put a point on, a focus on this today, understanding that there is now this move towards version 3.2 in order to get the tax credit as of January of this coming year, that is 2025, understanding that the current version 3.1 was to be 10% more efficient than the IECC 2012. And you can imagine, since 2021 is now in place in many areas of the country, many states, now the new focus is 10% more efficient than the 2021 code. And you can imagine that overall is a significant difference. Similarly, the thermal envelope, when you think about how to do an Energy Star house, you have many components that you can make changes to. The backstop, that is your envelope, had to be at least as good as the 2009 code. Well, it now needs to be at least as good as the 2021 code. And this is important for builders, energy raters on this call to recognize that your leeway of changing your enclosure is significantly reduced. There's less options, if you will. The enclosure options get just a little more expensive, and you are probably going to end up relying more on mechanical systems, air tightness. And you'll notice there the energy rating index in general for 3.1 was 55 to 65, now dropped to 45 to 55, at least that 10%, probably more like 20% improvement, which gives you a little less wiggle room on perhaps things that you can do to make a house meet those 3.2 requirements. And we're going to highlight one aspect of that, that is the ventilation aspect, but understand there is training available from others. Last week, I was on a webinar with the aero barrier folks talking about the opportunities associated with air tightness. And Pat, you and I would know that air tightness and ventilation go nicely hand in hand with respect to the software. Make houses tighter, put in better ventilation. There's real synergies to that. So we'll go to the next slide. And understanding within those technical requirements, I always like to point out that the updated reference house is now based on 2021 insulation levels. The air tightness level has now been set at 3 air changes per hour for all climate zones. So those of you in the South who used to be given a 4 air change mark, now you're at 3 air changes. The minimum furnace requirements is now 95%. And the ventilation, and this is important for today's conversation, is in accordance with ASHRAE 62.2, which is the 2010 or the 2013 version. And this again means for energy raters on this call to just check in and make sure you're meeting those requirements, because there are some significant differences in terms of how you quantify ventilation schedules that I'll just allude to, that Pat and Travis will talk about as well. We'll go to the next slide. And for those of you, I always like the Energy Star program, how they try to make things look simple, and they are. It's a 2-page checklist, but with 72 endnotes associated with it. And it's a minimum of 2 site visits, as energy raters will know. There is a requirement now for measured heating and cooling performance as per ACA 310, American Air Conditioning Contractors America, ACA 310, which is a significant change. And there's still, in fact, an updated version of verification of ventilation system performance and inspection of vents, ducts, and filters. So you want to put in ventilation solutions that you know can be verified in the field easily. And that too plays into the kinds of technologies that are available through Broan and other leading manufacturers. Next slide, please. And so I would just encourage you that there are these tremendous opportunities available to you with Energy Star version 3.2. I'm going to say to you, it's the next logical and reasonable step above the IEC 2021 code. In fact, the Energy Star program alludes to where things will be in the ICC 2024 code. It's one of the main benefits of Energy Star. It gives you a little bit of future proofing. You know where the codes are going. And nicely, hopefully you'll appreciate, especially after today, the industry has some important new technologies and techniques to make the transition to version 3.0 simpler and more cost-effective. Things like, as I alluded to, better air sealing technologies, new wall insulation options, and specifically for today, thinking about optimized energy recovery ventilation systems. And you're going to find that there's really nice synergies because these technologies simultaneously improve the comfort, durability, health of your houses while you're meeting the Energy Star 3.2 requirements. And that allows us to pass over to Pat and just go a little deeper into the technologies, or at least the intricacies of how you achieve the tax credit. So if we go to the next slide, and I'll just invite Pat in to take us from there. Pat, you've done a pretty thorough study of what are the requirements, and I know you want to help folks understand how to meet and accept those tax credits.
Yeah, thanks a lot, Gord. Appreciate it. So yeah, Pat Nielsen, Global Technical Products Manager here at Broan. So yeah, 45L, as you may have heard, it's in place now through 2032. And they simplified it, as I think Gord touched on. It's based on either Energy Star or Energy Star Zero Energy Ready as far as the levels that you can achieve in terms of dollar tax credit. A key thing, homes have to be certified, not just meet the requirements. You know, to Gord's point again, you know, you need third-party certification all along the way. And another change they recently announced is that sampling is no longer going to be allowed. So each dwelling has to be certified. So we'll focus on single family mostly here. So again, $2,500 for Energy Star. What does that mean in terms of ventilation? It requires dwelling unit ventilation. You know, in addition to all the spot ventilation for bathrooms and kitchens, it requires dwelling unit. If you're going to use the exhaust only for that bath fan has to be Energy Star. And also, when you're looking at your ERI or HERS score, the target home, if you're in zones 1 through 4, 4A and 4B, the reference home or target home is going to be a supply system, has to be at least 2.8 CFM per watt efficiency. If you're in zone 4C or 5 through 8, the reference or target home is going to be an exhaust fan at 2.8 CFM per watt. So I give you a little idea of what you need to beat to overcome. I have on the side here, on the right side, the climate zone map. One thing that's noteworthy about that, know that the 2021 IEC version of that, things shifted up a bit. We're here in Wisconsin. I always note that in the previous version, all of Wisconsin was in climate zone 6. And now, as you can see, the southern half is in climate zone 5. So, you know, really make sure you're not looking at an old climate zone map when you're considering these things. Secondly, to drop down at the $5,000 level, you hit that with an Energy Star Zero Energy Ready home. And note, if you're not aware, there's kind of a hierarchy. To get a Energy Star Indoor Air Plus certification, it requires Energy Star. And then to get Energy Star Zero Ready, it requires Energy Star and Indoor Air Plus. So they kind of build on each other. So the Indoor Air Plus says that if your DUV system is exhaust only, then they want you to think about the garage. They don't want pollutants from the garage making their way into the home. So the rater should either verify that there's a good seal between the garage and the home and that doorway, or put a 70 CFM garage fan in. So going down from there, if you're in climate zone 6 through 8, an ERV is required. And again, you see the target home requirements, you know, in more southern climate zones up to 4, your target home is going to be a supply system, at least 2.9 CFM per watt. And in the more northern climate zones, your comparison is going to be an ERV, at least 1.2 CFM per watt and 65% ASRE. So those are the requirements there. Real quickly, I'll touch on multifamily. and what's going on there. So there's four kind of cells, if you will, here. A basic Energy Star multifamily, you can get a $500 credit per unit. If you are also paying prevailing wage, that means you're paying at least the average wage to contractors in your area. That bumps way up to $2,500 per unit. Now, if you go down to Zero Energy Ready, you get $1,000 per unit. And if you do both those, build Zero Energy Ready and prevailing wage, $5,000 per unit. There's one more there. And for manufactured housing, if we have any of those folks out there, your goal there is to build Energy Star. And if you do that, you get the same $2,500 you do for a regular single family home. And once again, dwelling unit ventilation is required. So here, this is a very important distinction. Most things when it comes to code are based on permit date, right? That's historically been the case. When they passed this 45L legislation as part of the Inflation Reduction Act, they made this based on acquisition date. So this wasn't Energy Star's decision. This was a Congress decision, part of the legislation. So for those homes that you builders are going to be turning over the keys on after January 1, 2025, if you want your credit, you have to be hitting 3.2 version Energy Star now. So very important distinction. And the multifamily version will not be changing. It doesn't change until 2026. So what does this mean? How do we hit that? Gord kind of touched on this. In terms of ventilation, when you go from version 3.1 to 3.2, there are no additional checklist items. But as he mentioned, your target HERS range is going to drop about 10 points. You know, it depends on what climate zone you're in and so on, but on average, it's going to drop about 10 points. How you can gain those points, you know, in terms of a efficient ventilation system, you know, it depends on what energy code you're comparing to. Obviously, climate zone, how large is your home, how efficient is your heating and cooling system. The less efficient that system is, the more important it's going to be to have an efficient ventilation system. Say an ERV, they're going to save you even more. What system are you comparing it to? You know, if you're just using a CFIS system today and you jump to ERV, there's going to be more savings there because CFIS systems aren't particularly efficient, for instance. And then, of course, you know, how efficient is your bath fan or how efficient is your SRE performance on your ERV? This small little chart to the right, Gord touched on this, but kind of another way to look at it as far as the illustration is you look from left to right as the years have gone on, you can see how Energy Star is always staying one step ahead of the latest IECC energy code. So as he mentioned, the current version 3.2 is going to be about 10% better than the 2021 energy code. Go ahead. So a few other things. So how can Broan help you get there? Very importantly, very basically, bath fans, when they're used for DUV, they have to be Energy Star. So today you can reach Energy Star certification with a bath fan without it having a DC or ECM motor. But that's the very bottom baseline. But if you use a product with a DC ECM, such as our new Broan Evolve series, which Heidi will talk to you more about, you can save up to a HERS point. It may not sound like a big deal, but for you builders out there scrambling for HERS points, you know, one HERS point is a big deal. And, you know, a bath fan is a very cost-efficient way to go get that HERS point. And the other thing with bath fan is those HERS points don't change based on climate zone. You know, if you're saving X amount of watts between this bath fan and this one, it doesn't matter if you're in climate zone 7 or climate zone 2, the wattage is wattage. So it's consistent. So at that, I will turn it over to Heidi to tell you a little bit more about our new Evolve line.
Hello, everyone. Travis, can you go to the next slide for me? So once again, I'm Heidi, Senior Product Manager for the EV team, and I'm really excited to be able to talk to you all about Evolve. So just want to show you a couple of fun pictures of Evolve. One thing to summarize here with Evolve, our new line, is a combination of both fan and fan lit in 2 base models. So that's going to be in a 50/80/110 and a 110/130/150. So as you heard from Gord and Patrick, performance and noise are two key things that are considered when selecting a fan for both code as well as just overall appearance of the fan. With Evolve, we're really excited to be able to offer these three main claims, which are guaranteed performance with true CFM, a near silent operation, and a savings of up to 30%. Our near silent operation does come with less than one zone to the ear when you are listening for that fan. The second thing is we can offer up to 30% to the contractor on installation, which does include a patent spring-free grill design, which we're super excited about. Now let's take a deeper look into that guaranteed performance. So when we talk about guaranteed performance, we're really trying to highlight how the air can continue to flow up to 0.4 static pressure. So with Evolve, we can really guarantee that performance. And I'll show you here in just a couple of moments when we put it on the graph where it starts to shake out and what it starts to look like. But as it shows on there, 0.4 does consider both bends and turns, as there isn't ever a perfect fit for a type of ducting. And really to the contractor, to the builder, to your energy raters, it's really reducing those callbacks and red tags. So like I just mentioned before, when we look at Evolve, when we start to stack it on the graph, you can start to see from the graph here that's on the screen, the blue is going to be a Broan, and then our red, orange that you're seeing on the screen is our top competitor. So as you take a deeper look into the graph itself, you start to see that our competition, our lead competitor, starts to drop off around 0.25 static pressure, and Broan is consistently either exceeding or holding the true CFM level up into that guaranteed performance of 0.4, even a little bit above. So we know, as Gord and Patrick talked about before, ASHRAE 62.2 is a huge part of the DUV. And as we start to look at Evolve, you can have confidence in code compliance with Evolve and be able to efficiently and effectively have a product that will reduce your call tags across the board with Evolve. So once again, with the HERS rating, Evolve can save you up to 0.1 of a point. Once again, that's up to 1 Hertz point by having a watt range of 0.6 to 10.6 watts. Once again, I wanted to drop in here for you. The graphs on the right do show performance both for the 50, 80, 110, and then the 110, 130, 150. Really wanting to capitalize here, one, consistently able to hold that true CFM, that guaranteed performance at a near silent operation while considering aesthetic looks into the home. Thank you all for your time, and I really appreciate it, and I'd like to pass it back to Patrick to really give you a little bit more detail around HERS for ERVs.
Thank you, Heidi. Just finishing up on Heidi's thoughts there. Gord, I assume that's something you see is important to builders when you look at those very low bath fan watts on the Evolve series?
Yeah, it is interesting, and Heidi kind of stated it, and maybe you said it as well. One HERS point, it's not that big a deal, but it is a big deal as you get tighter and tighter on these requirements, getting down to HERS ratings of 45 and so on. It gets more and more challenging, more difficult to move the needle. So being able to check that box and saying, yes, I have that, it is really powerful. I don't want to dismiss either, though, the need for verification of flow. Your energy raters don't want to get out to that site, on their last inspection and find they're not getting that flow. And we know there's been challenges in the industry across the country with I'm going to say the explosion of Energy Star houses. You'll see new manufacturers come to the table and perhaps offering some claims, but then when you get out in the field. So there's two things important at the design phase, knowing you've got that point, and then at the verification phase to make sure you're confident you're going to get those airflow ratings. So when the energy rater is doing their final checklist, field checklist, they can check off that box. Really important, both aspects. Taking away, I would say, just some of the stress of meeting requirements.
Yeah, thanks, Gord. So I'll have one quick slide here to kind of set Travis up in terms of how much, in terms of HERS points, can ERVs save you. As I mentioned earlier, a couple big things. It depends on your climate zone, and it depends on what you're comparing to. What system were you going to put in if you didn't put in an ERV? So here are a few examples. If you're more in northern climates like 6, it can save you 6 points compared to an exhaust fan, a basic Energy Star certified exhaust fan. if you're down in zone 2, you can see zone 2, Houston, the southeast can save you 4 points compared to a CFA system, fan integrated system, and 2 points compared to an Energy Star certified supply fan. Again, also a supply system, but a dedicated fan as opposed to a CFA system. So again, the new Broan AI series and the Broan-1 can help you get these very easily and efficiently. So I'll turn it over to Travis Moore to tell you a little bit more about those.
Yep, thanks, Pat. Travis Rash, Group Product Manager for our fresh air systems. And again, very thankful for the opportunity to cover our new Broan-1, launched in late May, early June of this year. So when we set out, when it came to the scoping of Broan-1, the main message we got back from the field, builders, contractors, raters, etc., was how do we simplify this process? We have different plans, single family, townhome, multifamily, and even within those multifamilies, you have numerous different plans. So how is it that we can design and specify around one ERV? How does distribution, contractor, etc., order, stock, and distribute one ERV? So these are common asks that we heard during that new product development process, and ultimately from the end user standpoint, homeowner, builder, etc. How do I install and maintain one ERV? And so that was the mentality that we brought into the design process when it came to launching this new product. So to give a little bit of a high-level overview of the Broan-1, we start out with a low-profile design. Again, direct feedback from the field. That low-profile design lended itself well to be able to fit in various locations as well as accommodate different applications. The product includes our virtual technology. This is a technology we launched in late 2020 with our AI series platform. And again, something that's been tried and true to out in the field. And it really lends itself well to numerous stakeholders along the way, which we'll cover here in a second. Filtration. So Gord hit on it, Patrick hit on it, as it relates to that indoor air quality piece and abiding by those new regulations, both in code, but also within the Energy Star program. MERV filtration. So MERV 8 is now becoming the standard, both in codes as well as that Energy Star Indoor Air Plus program. So making sure that the unit out of the box had that MERV 8 filter, in this case, a washable MERV 8 filter. So from a homeowner standpoint or servicing contractor standpoint, that maintenance is done pretty easily when it comes to this filtration. And for those customers looking for additional filtration capability, we have an optional 2-inch thick MERV 13 filter. For those in the California market, that'll ring to your ears because it is a requirement for any kind of outdoor air supply to have that MERV 13 and 2-inch thick MERV 13 filter option. We knew going in and using our old platforms, the ability to adjust CFM is critical. So you guys have different applications, home size wise, number of bedrooms, etc. The expectation for those airflows was becoming wider and wider. And so with the use of our ECM motors, you have the ability to adjust that CFM from 35 all the way up to 155 at 0.2 in 1 CFR increments. So you have that ability to fine tune based on that floor plan, based on those design requirements, what it is you need for that ventilation rate. And finally, the sensible recovery efficiency. So how good is this product at taking that outdoor air and using the indoor stale polluted air to do some work? So again, you're going to see those percentages. And to give an idea for those unfamiliar, 80 plus SRE is kind of the benchmark, or it's becoming more the benchmark. So if you can get above that 80+%, you're doing quite well as relates to the other products related out in the market. Probably the biggest differentiator for this new product out in the field is the infield selective airflow configuration. And what this means is today we have 2 different models or previous models. You had a standard airflow and a mirrored airflow model. And what we were really considering is where the exterior ductwork ran to and from the unit. So with the use of an integrated switch that's physically on the product itself, you have the ability to dictate on which side of the ERV your exterior ductwork is running. And why this matters, and again, this is direct feedback from the field, as you can see here, a good example of a multifamily application, mirrored floor plan across a shared wall. The design engineer decided the right spot to put this ERV was in this particular place. And when they took that same model and tried to simply add it or flip it to the other side of that mirrored floor plan, you can kind of see what the ductwork does. So we've got to basically do 180s or back, turn the ductwork around on itself to try to get, again, maintain that same location, but get that ductwork to the places that it needs to go. So that's where this in-field selective airflow configuration with this switch really comes in handy, is you can keep that ERV in the same spot. You've decided what the best spot for that ERV is for various reasons. And with the simple move of that switch from one side to the other, you can dictate on which side of the ERV that exterior ductwork is running to. And so you can see there the problem and ultimately the solution and how clean that ductwork is. And really what this boils down to is simplifying. So we've simplified that product location. I'm not concerned with, can I put it in this side or that side, depending on the floor plan? It's in the same spot. Model specification. Again, before you're having to specify one model and then a mirrored model. No longer are we doing that. When you guys are putting those ERV tags on or marks on your floor plans, it's the same SKU number. You're not concerned with making sure I got a 50-50 chance of whether I've got it right or wrong. So simplifying that overall process during the design and specification side. Ductwork routing. So you saw the previous pictures. It kind of explains itself. We've got nice, clean ductwork, which ultimately lends itself to making sure when that CFM is specified, when that ductwork is clean, we're eliminating or reducing the opportunity out in the field to get have a little creative freedom. And so the ductwork itself stays pretty true to the design. And again, we're hitting the CFM that we're expecting that you have specified for that application. And finally, that install configuration. So particularly those multifamily applications where you're kind of rinse and repeat, floor plan to floor plan or floor to floor, making sure that ERV is always installed in a consistent manner, the same location, really lends itself well to eliminating or reducing the number of opportunities for things to go wrong in the field itself or during that verification process. And finally, the Virtua technology. And so there's really three key things that Virtua does for the installing contractor, ultimately the builder, and ultimately the homeowner. And the first is that balancing process. So for those that have installed these types of products and gone through that balancing procedure of the old days, you're using gauges, measurement gauges, magnehelic gauges, manometers, making adjustments to dampers or to fan speed of the unit itself. No longer is that required with Virtua. So the unit auto balances, saving up to 20 minutes per install. And so particularly if you're in those multifamily applications, 20 minutes adds up quite quickly. We've got guys out in the field that are doing 3 to 4 of these a day in the single family side. And again, if you can save them 20 minutes per install, that's another time they can either do another job or quote more competitively. And again, toolless configuration. So we're not concerned about having to use tools to commission this product or adjust dampers, etc. It's all done on that screen that you see on the product itself. And again, easy to interact with, whether you're a seasoned contractor or a brand new contractor, you have the ability to interact with the product right with that screen. Self-adjusting. So we all know things change. Filters can accumulate over debris over time, terminations, ductwork, etc. Virtua is going to step in and make that self-adjustment. So it's going to detect those conditions in real time and stay balanced. So once that unit's commissioned for the first time and balanced, it's going to stay balanced throughout the life of the product. And finally, artificial intelligence. So it's a hot word. Basically what this does is we have, for lack of a better term, taught the product through thousands of different scenarios. When X happens, do this. There's things we haven't thought of. So there's items within the product itself that we can use as levers to always get back to that set CFM that was done at the very first step of the commissioning. So again, always coming back to that reliable airflow that we're expecting and your application needs. So with that, we're going to talk as it relates to energy modeling and these inputs and what to consider for those ERVs. So I show here 2 common energy modeling softwares, the first being Ecotrope and the other one being REMRate. And kind of walking through when you're looking at the ERVs, what are the key things that when you do that input that you should be considering? And the first is that recovery efficiency. So depending on the program, it might be called something different. With Ecotrope, it's called energy recovery percentage. In this case, this is the ASRE, or adjusted sensible recovery efficiency. This is a spec that you're going to find on our HVI directory or directly in Broan's specification sheets as well. So that ASRE and ATRE, or adjusted total recovery efficiency, in the case of REM rate, what that's doing is it's separating the watt usage of the product compared to the actual recovery efficiency of the ERV itself. So this is a key metric that you're going to input during that modeling process to ultimately get to you what the HERS impact is of an ERV. The next is the wattage. So how good am I at producing airflow at the electricity I'm using? So you're going to see a fan efficacy or fan wattage. This could be at a complete watt rate that you need to input, or a fan efficacy, or CFM per watt. So again, Pat talked about it, Gord talked about it. Again, wattage is wattage. So whether you're in climate zone 2 or climate zone 7, a watt is a watt. And so we want to make sure that the input for this is being done correctly, because it is going to make a significant impact as it relates to how this ERV models in the long run. Operational hours. So some of the older systems could work intermittently. With an ERV, with that sensible recovery efficiency, the filtration that we talked about, it's more typical to model these being running 24/7. So, and that also accompanies lower CFM. So it is a continuous ventilation rate value that we are looking to achieve. And with an ERV, with that sensible recovery efficiency, with the filtration that we're getting, it's common practice to have these operate 24 hours a day, 7 days a week, 365. And again, there's a rhetorical question, when do you want fresh filtered air? And the short answer is all the time. And so that's where you're going to see the operational hours input being 24 hours a day. Also, you'll see when you look at our values and specification sheets on HVI directory, you're going to see the watt usage drop pretty dramatically as you go lower CFM. So again, we're spinning those motors at lower RPM, which ultimately relates to lower watt usage. And again, more of a trickle effect versus trying to run full tilt for a short period of time out of that 1 hour or 4 hours, depending on what you're trying to achieve is. And again, this all comes back to that HERS improvement. So Pat showed earlier on, depending on what climate zone you're in, you can see a significant difference in that HERS improvement. Same thing too, there is a cost associated with reaching these new Energy Star and Zero Energy Ready Home initiatives. So looking at the cost benefit as well as that code compliance, depending on where it is you're building and what codes you're trying to comply to, you may see that you're going to be able to check off a number of additional boxes by using an ERV when compared to some of the other options when it comes to meeting that code. So again, there's always a cost or a gap analysis that's done, making sure that ERV is modeled correctly, like we talked about here, as well as, again, knocking out a couple birds with that one stone and hitting your code compliance, but also meeting that HERS improvement score that you're looking to. So I guess, Gordon, knowing what you know and seeing all the different designs and things of that nature throughout North America, is there anything you can add as it relates to maybe the use of ERVs throughout the U.S. as well as just North America in general?
Well, I'm gonna play old guy, and I'm gonna say, if anybody was watching, I was smiling and nodding my head throughout your entire presentation, because I'm a guy who 40 years ago, literally 40 years ago, was designing, I'm gonna say, generation 2 of HRVs. And many of the things that you just mentioned, we were trying to check those boxes off 40 years ago, couldn't do it. The whole piece about verified flow and knowing exactly what the flow is, knowing how to balance the installation configuration and the messy ductwork. You guys have just done a phenomenal job. I can also say with a high degree of assurance, because I was just cleaning up my office, 40 old records of the initial cost of HRVs 40 years ago, the price has actually come down in hard dollars, not in today's dollars, but in hard dollars, actually come down in price. So thank you for getting all of those things done. But on this slide specifically, I'm going to say, because ERVs, energy recovery ventilators, are new in many markets, not that familiar, and because there's been a proliferation of models in the market, that it is true that some energy raters and mechanical contractors and even supply houses are struggling a little bit with exactly what do I put in? Where do I enter? So let's start with, you mentioned the name HVI, the Home Ventilating Institute has a standard that ERVs are tested to, and they list the performance characteristics. So HVI.org, look up the individual models, and then be very careful about what you're entering in. As Travis mentioned, that adjusted sensible recovery efficiency. Where exactly do I pick that off on the HVI sheet? What number should I be using? Because you do need to know in the HVI sheet, it's taking into account the apparent efficiency. That is, if you just put some thermometers on the unit, what would the efficiency look like? And then in certain cases, it's backing out the fan wattage. And what Travis is suggesting to you is that you need to be very careful on how you input that. The good news is you're going to rely on the Broan network, Heidi and her team, Travis and his team, to help you understand. And if you're struggling at all, energy raters struggling at all with how do you make these inputs, it's really important to your builders to check, because it can make the difference of a couple of hertz points if you're not inputting this correctly. Even at ones, it comes down to operational hours, understanding that in the software, the energy rating index, there is a relationship between air tightness and ventilation. That is, as you make a house tighter, the ventilation, in order to make up the ventilation for the house, the ventilation system ends up running longer. So the very fact that Energy Star 3.2 has now made all houses as models a minimum of 3 air changes per hour on leakage, that's going to affect how much, say, an exhaust-only system or a supply-only system runs, and you're going to get better synergies as you get to lower air leakage rates, better synergies out of the ERV rate. So energy raters, really important that you take a few minutes, speak with, I'm going to say that the field team, and if you're confused at all, the field team at Broan, if you're confused at all, by all means, reach out to us at Construction Instruction if need be. Just to make sure you're getting those inputs correctly, because it can make a significant difference to your builders who are working really hard to improve air tightness. And let's be really clear, improving air tightness of a building is really important from a noise, dust, humidity control in the southeast, in the hot, humid climates. People say, oh, it's a hot, humid climate, we don't need to be airtight. No, that's exactly where you need to be airtight. You want to keep out that moisture. In terms of natural air leakage, and then using an ERV to help managing that moisture load as well. So take this chance in the next month or so to check in, validate your modeling assumptions to ensure that you're getting your builders the best possible points. And if you're hearing builders from your energy raters that ERVs don't make a difference, don't move the hertz points, I would question them and say, have you worked with the appropriate people to ensure that we're getting credit for our air tightness, getting credit for the fan watt draw? So hopefully I'm not overstating that enough. Start with the HVI listing, independent. Just go to the HVI.org. It's independent test results, and then make sure that you're putting in the right inputs to optimize the performance at the design phase. And then I will go one last time and say, for energy raters, boy, it's going to be nice for you to know that once this piece of equipment's installed, you don't have to measure airflows. The unit's already doing it for you. It's validating or verifying the flows right on the box itself. So that's a huge input for you folks.
Yeah, thanks, Gordon. To everybody attending this, as well as shortly in the future here, you're going to see more materials from Broan coming out as relates to the modeling inputs, these types of considerations. So we're going to take an additional step and go a little bit further in those details for you guys and provide that type of information. So as Gordon mentioned, as you're having those conversations with your builders or as a builder itself, making sure that all these inputs are done correctly, because you will realize a benefit in your energy modeling, obviously, when the inputs are done correctly in the first place. So I think with that, Pascal, Any questions or anything that came up in the Q&A while we were?
Yes, we have one question from Josh. And this is one I've heard a few times now. And maybe Travis, I know you can relate to this one as well. Do we have to derate for air density in altitude?
So yeah, altitude, and those that are in altitude, you're familiar with the term correction factor. And so there is a correction factor related to altitude depending on how high above sea level you are. And we do provide that information in the respective model manuals. So you're going to see a correction factor related to at what altitude is the actual corrected airflow. So again, air density changes, how our product interacts with that air. You will see that correction factor for the given model in our specification sheet install manual. So we do provide that detail for that particular condition. Good question.
It's a really interesting question for me. This is a pretty deep dive, right? This first question out the chute, a pretty deep dive. Thank you, Josh, for thinking of this. Most folks are just going, what the heck does E stand for in energy recovery ventilator? And here you are at a pretty deep level. And just recognizing the air density does have an impact on the energy associated with ventilation. It's not taken into account in the, let's call it the IEQ side. That is the amount of air, the volumetric flow of air is really what you're looking at from a ventilation perspective, an air quality perspective. So in terms of field verification, I would say it's more of a modeling exercise as opposed to a field verification. I wouldn't be correcting the flows. My opinion wouldn't be correcting the flows based on from a verification out in the field. But from an energy modeling perspective, it has an impact.
Thank you, Gord, for this clarification. We have another question here, and this one is for Heidi regarding Evolve. And it is from Colby. I hope I'm pronouncing your name right. Where was the true CFM testing for the Evolve line performed? Is it from a third party or internal lab?
Great question. So one super exciting thing for Broan is we actually have our own HVI UL certified internal lab. So here our lab team performs all of the required UL and HVI certifications here in-house. So we do that internally and then get submitted in. So once again, we have UL here, we have HVI here multiple times throughout the years to check and make sure we are performing everything to the certification that it needs. So with that being said, we do that internally, but does get tested as well third party in regards to how it is looked at as well. So once again, done both internally by our HVI team here in-house as well as it is looked at third party. Great question.
And as an outsider to the manufacturers, I feel like I want to state HVI is a pretty interesting organization. It's not really a standards body. It's an Home Ventilating Institute is an industry association, and within it there's a challenge procedure. So if you don't believe, if one manufacturer doesn't believe another manufacturer's numbers, they can challenge that. And that's not familiar, right, to most folks with ASTM standards and so on. So there's an interesting sidebar to HVI that the manufacturers are policing themselves, doing a nice job of it, quite frankly. And that's why I would always say you always want to look for HVI stickers, and you're going to see, because of the proliferation of models, you're going to see lots of equipment, or at least a few pieces of equipment coming from elsewhere that are not HVI. So look for that HVI certificate. It's been, boy, it helps straighten out. Again, a guy 40 years ago, like me, designing HRVs, there was no independent third parties back then, and we were all claiming over 100% efficient. And once we ascribed to the HVI process, boy, it cleaned up the industry pretty nicely. And so it's nice to know that's there as a backstop.
Absolutely.
I'll just add to that. I'm very involved in HVI. They also have a verification test procedure. So HVI randomly goes out and buys products on the market and tests them. And another way they hold manufacturers' feet to the fire that, they're meeting their performance certified levels.
And Pat, I think it's nice for you to know that the leading manufacturers, some of the brands that folks are associated that understand are it's nice when you see their name listed. It gives you confidence that you were not fighting over over whether somebody's numbers are believable or not, as long as they've got that HVI label on it. It's really powerful.
And most of the code language now requires HVI certified ventilation products, so.
Right.
Right. We don't have any more questions from our participants, but we still have 5 minutes and I took some notes, so I'd like to ask one myself or maybe just.
Pascal, it does look like one just came in from Daryl.
Oh yeah, you see it? Okay, go ahead, you can read it.
Yep. So the question from Daryl is, can you connect the ERV to an air handling unit when it's used for continuous ventilation? And Daryl, the question is yes, or the answer is yes. Becoming more of a prominent install type is using the fresh air that exits out of the ERV, so that tempered filtered air, that will go into the return side of the air handling system. And with that airflow being distributed in the return side, a couple additional benefits. Not only do you already have the filtration happening once through the ERV itself, when it goes in that return side, it makes its way through that return filter, you're getting additional filtration, as well as depending on if the heating and cooling system is running at that time, you'll get additional tempering. So when you put it into the return and you're taking stale air from either the dwelling, you can run the ERV without the air handler fan running. It is the time in which we need that air handler fan to run is if we were to take the stale air from the return and distribute the fresh air from the ERV back into the return side. Because if we don't do that, and we don't get that air handler fan on, we're just going to create a closed loop and just move air basically through the return through the ERV back and forth. So the only time that the air handler fan would be required to run is if we're in that return to return type setup that I just described. Otherwise, it would be able to run that ERV without having to run that air handler fan. I will put a little bit of caveat to another option to do is if you're using that air handling system ductwork, is if you were to take the air from the Atria ERV and distribute it into the supply side, we do want to be mindful of that supply side ductwork temperature. So if it's in a conditioned space and we're in an extremely cold climate, so while yes, the Atria ERV is doing its job by tempering, we are still distributing that air into a tempered space or into tempered ductwork. So we do want to be mindful of that, as well as depending on what the closest supply register is, be mindful of where that's entering into the home itself. But yeah, short answer is only when you're in that return to return do we truly have to run the air handler fan. And if we're in that, if we are distributing that fresh air from the ERV or HRV into the supply side, we just got additional consideration that we're mindful of. Another question from Larry. Can all of the participants get a copy of the presentation? So it looks like that has been answered. Yep.
Yep. Yeah, I did answer that. And yes, everyone will get a copy of the presentation as well as a link to watch the recording again if you want to. And this will be sent by email in just a few days.
Okay. So another question came in from Daryl. Yep. Does Broan recommend a duct type to be used for the new exhaust fans with the guaranteed flow rate? I guess it could be rigid, it could be flex, but ultimately it still needs to be 4-inch or 6-inch.
Correct. Yeah. It could be either one. Yeah, that's where I wanted just to confirm I wasn't assuming the wrong direction, but yes, it could be either one. But
rigid is always better in terms of static pressure, keeping that to a minimum.
Okay. We are right at time. Gord, on behalf of Broan, we thank you for your participation, as always.
Absolutely. Thank you so much, Gord, and to our 4 presenters, and obviously to our participants. Hopefully the information we covered was valuable. In case you want to see the slides or watch the presentation, as I mentioned earlier, you will get a link to do so. In this email, you will also have the contact information should you have any additional questions or comments about the webinar.
Thanks for including me, Pascal, Travis, Pat, Heidi. Nice to see you all.
Thank you so much. On that note, goodbye.